Good afternoon, economists. Today I'm going to do a quick little video where I go over some of the homework problems that I thought people might have problems with or are having problems with. I'm going to try and go through it pretty fast and furious because that assignment is due. If you have any questions, let me know. All right, so let's get after it. I'm going to use the .cam for this first problem. This is a problem that came up in class looking at two labor markets, Sector 1 and Sector 2, and finding the equilibrium wage, labor demand, and then looking at what happens when one of the markets encounters a minimum wage law. Okay, so I'm going to go ahead and turn it over to the .cam. Okay, so this first problem is in the textbook, and it's in the assignment in the textbook. It's question 1.8, and it basically says that we have labor demand in two different sectors. In Sector 1, labor demand is L1 equal to A minus B times the wage. In Sector 2, the labor demand is L2 equals C minus D times the wage. And then the labor supply for both sectors is equal to L equals E plus F wage. And so the first thing we want to do is solve for the equilibrium. We want to remember that equilibrium occurs when the two demand the labor demanded in both sectors is equal to the labor supplied. And so that's how we'll write this problem out. So I'll start by setting L1 plus L2 equal to L. So A minus B W plus C minus DW equals E plus FW. And then, I'm going to zoom in a little bit. It's a little bit hard to see there. And then we just solve for wages. So I'm going to start by organizing terms. And so that's just to kind of to get the constants that aren't attached to wage next to each other. So that's going to be A plus C minus BW minus DW equals E plus FW. And then I'll go ahead and subtract these over both of these wage coefficients and bring them over here and subtract E to bring it over here. So now I have A plus C minus E equals FW plus BW plus DW. And then I can factor wage out of this side, and I'm going to get A plus C minus E is equal to, I'll kind of organize these so they're in alphabetical order, B plus D plus F times wage. And now I can divide these constants from both sides, and I'll end up with wage is equal to A plus C minus E over B plus D plus F. So that's our first equilibrium wage. That is the wage at which this market is in equilibrium. And then we can, of course, insert that into our market demand and market supply functions. And so what we would get there is L1 equals A minus B times this wage, A plus C minus E over B plus D plus F. L2, labor demand in the second sector, is going to be C minus D times A plus C minus E over B plus D plus F. So far, so good. And then the same thing for the labor in both sectors. And we can solve for that by, again, getting the fact that we have these terms organized over here. We can say that the labor overall is equal to that, right? The labor supply is equal to L1 plus L2, which is A minus BW plus C minus DW, or A plus C minus B plus D times wage, which is L equal to A plus C minus B plus D times A plus C minus E over B plus D plus F. So far, so good. The next thing we want to, ran out of space. There we go. Now you can see it. The next thing we want to do is talk about what would happen if there was a minimum wage in one sector. So the next part says there is a minimum wage, which is equal to W line. That's not confusing, but it's only in sector 1. So this is where, in this question, I believe they ask you to look at, okay, well, what's the wage in sector 1? What's the wage in sector 2? What's the labor demand in sector 1? What's the labor demand in sector 2? What's the labor supply? Let's start with the easy one. The easiest one is going to be sector 1, right? So the wage in sector 1, wage 1, is just going to be that W bar. Before, we didn't have to differentiate. The wage was the same in both markets because the markets were treated the same way. Now we have a wage in sector 1, and it's that minimum wage law. The labor the labor demand in sector 1 is going to be that same function, A plus B, but now it's a function of that minimum wage. So that's the easy part, right? The more complicated thing is to solve for the new labor demand and wage in the other markets. And so that's what we're going to do next. So I'm going to shift my camera here so I can get a little more length. Woo! That worked perfectly. So now we want to find the labor demand in the second market and the wage in the second market. So what we can do is say, first what we want to do is find the equilibrium wage just like we did before. So we did L1 plus L2 equals L. So we're going to do the same thing down here. But now L1 plus L2 is A plus B W bar is going to be added to A minus B. That's a mistake because the labor demand is going to be inverse to wage, right? It's going to have a negative relationship to wage. There we go. A minus B at that minimum wage, and then sector 2 is going to have labor demand of C minus DW, and that's the not minimum wage. And we're going to set all of that equal to the labor supply from above down here, which is E plus FW. And then we go ahead and solve in the same way we did before. So now I'm going to collect the terms that are similar. And so I'm going to get A plus C minus DW minus BW bar equals E plus FW. And then I'm going to collect my two wages over here. or else to collect my 2 wages over there and collect all of my other terms over here. So now I have A plus C minus BW bar minus E is equal to DW plus FW, right? Subtract this, or add this to both sides, subtract this from both sides. And then I can factor the D and the F out and divide by it. So I'm running out of space here, but you can kind of see where it's going, right? Same as the way we solved it before. Now it's going to be all of this divided by this. So wage is now equal to A plus C minus B W bar divided by D plus F. That's our... Okay, sorry about that. Something's going on and Camtasia is mad at me, but this is our wage in sector 1. This is our labor in sector 1, and now we have our wage in sector 2. So we can solve for the labor in sector 2 and the weight and the labor demand and the labor supply. So again, the labor demand in sector 2 is going to be that L2 equals C minus DW. So now we just insert this W in. So L2 equals C minus D times A plus C minus BW bar divided by D plus F, right? I think that's all the parts they want you to find. They might want you to also find the labor supply, but you shouldn't need it to answer the question. But we could put that together too, right? We could solve for L equals EF and that wage, right? It would just be labor supply is equal to E plus F, A plus C minus B. Oops, I left one out. Woo! Minus E, right? BW bar minus E divided by DF. I dropped it from over here when I finished the answer. Do you see how that happened? We need A plus C minus BW minus E. There it is. That's the correct answer. Cool, so hopefully that helps you answer it. The last thing it asks you to do is what happens if the minimum wage is in there for the whole market. And that's pretty straightforward. If we had the minimum wage in place for the entire market, L1 would be this, L2, would be, you see, this, L3 would be this, and we would solve for it in the exact same way and get the same outcomes, right? So we could also solve for L as being, the labor supply as being L equal to A plus C minus D plus B times W bar, if the minimum wage was over everything. So that's how you solve that problem, okay? Another problem that should be pretty straightforward, but I figured I'd go over, was question 1 in the MyLab and text question 1.1, which was looking at solving for multiple equilibria with multiple demand curves. So the way we have this problem set up is we have 2 markets. The first market has a demand function equal to 30 minus 2P1 plus P2, and demand in the market 2 is equal to 30 minus 2P2 plus P1. And we can see already that these must be, sorry, I get the camera readjusted, there we go. These must be substitute goods, because when the price of good 1 goes down, the quantity demanded goes up. When the price of good 2 goes down, the quantity demanded of good 2 goes down. So That tells us a little bit about these goods. We also know that the quantity demanded in these markets for Q1 is 27, and for Q2 is 24. And so what we can do is insert this quantity into one of these formulas and then solve for the price in one, and then use that to solve for the price in the other. Hopefully that's pretty straightforward. So we'll start with our Q2 is 24 equal to 30 minus 2P2 plus P1, which gives us 0 equals 6 minus 2P2 plus P1. I'll put 2P2 over here. 2P2 equals 6 plus P1. And then divide both sides by 2. P2 equals 3 plus 0.5, or 1/2 P1. Now I can insert that into the other equation, or if you wanted to start with Q1, you could. And with Q1, we'd have 27 is equal to 30 minus 2P1 plus P2, or 0 equals 3 minus 2P1 plus P2. 2P2 equals 3 plus P2. 2P1 equals 30, so P1 equals 1.5 plus 0.5 P2. So those are the two equations, and we can insert one into the other to get a solution. So for example, I can take this P1 equation and insert it in here, or really any stage, because we'll get the same outcome either way. It's kind of the easiest to stick it in actually right here, because we don't have to do any multiplying. If we think about it this way, we just go 0 equals 6 minus 2P2 plus 1.5 plus 0.5 P2, which gives us 6 plus 1.5 is going to be 7.5. Minus 2 plus 1/2 is going to give us 1.5 P2. And then just add 1.5 P2 to both sides. And then divide by 1.5, so that P2 is now equal to $5. And then we could even just insert that in over here and say, well, P1 is equal to 1.5 plus 0.5 times 5, which gives us a total price for P1 of $4. So these two markets are related. They've given us these two outcomes, and now we have two equilibrium quantities with two demand functions and two prices. So that's how you can solve a lot of these general equilibrium questions. The other thing you want to think about is generally, like, how do these markets go together? How are these markets related? And what effect would they have on each other's supply and demand? The last question I wanted to go over with y'all is about the production possibilities frontiers for two people. There's a couple of different versions of this. Golly, that seems far back. That's better. I don't have that much desk space, so I don't have a lot to play with. In the textbook, this is question 4.2. I believe it's one of the last questions in the multiple choice in the My Econ Lab. And there's a bunch of versions of this. I'll do one version, but you can kind of get the idea of it for all of them. So we have two production possibilities frontiers in the My Econ Lab. I think it's Billery and Hill. That's sort of funny. But let's do an example here where I've got, say, two PPFs for two individuals. And then what I want to do is combine them and then find out how much they produce. So let's say I've got 2, 4, 6, 8, 10, 12. And this is one of those cases where being a little bit more accurate with your scale is going to help you out on this one. So I've got my first PPF is going to be from Hill, who's going to have a production possibilities frontier going from, let's see, 4 to 4. So that's the PPF for that individual. I think I have a pen that'll help me do that. And then I have a PPF for the other individual, and that's going to go from 5 to 10. And this is a situation where I'm going to do something I don't normally do, and I'm going to get out my straight edge and kind of try and make these look pretty nice, because it's going to help when I add the PPFs together in just a moment. Because in this case, it's going to be really important to try and be accurate about the slope of these production possibilities frontiers. So now I'm going to combine the two, and that's the first part, is you want to combine these two PPFs. So what you do is, first you finish labeling them with your superfine, I like to use this to label blue pen. So the PPF for biliary. And then what I want to do is go ahead and draw the joint PPF. And so I want to sum here and say, okay, if I combine this and this PPF, this produces 5, this produces 4, 5 plus 4 is 9. So I'm going to start up here at 9. And I'm going to take this slope down to the point where I get to 10. And then I'm going to want to extend it out another 4, which means I'm going to need a much longer x-axis. That's okay, because I can create it. There's 12, there's 14, there's 16, just for good measure. So let me show you what I mean. If this is the slope of my first PPF, I want to start out up at, I want to hold that slope, start out up at 9, and take it down just as far up to this point 10, right, to the quantity of 10. And that's where there's going to be a bit of a kink, because now I'm going to add on the additional productivity of the second individual, which takes me with this same slope here over to 14. And it's going to be a little bit less kinked than I want it to be because it's not quite to scale, which again is one of these times when it does help to be a little bit more to scale, but that's okay. We'll just say that this is 14. And this is something else entirely. So now I have a larger PPF for the population, for the total world. And there's sort of this kink here where this PPF attaches to this PPF. And that gives us the total productivity. That part's pretty straightforward, right? Draw the combined PPF. Now we are given the sort of second part of it, which says, given the price of the two goods, in this case, we have good Y and good X. Let's say that the price of, let's say, given the prices of the goods. How much does each person produce? And to solve this problem, you need to remember the rule, which says that it's going to be a function of the absolute value of the marginal rate of transformation relative to the absolute value of the ratio of the prices. So let's calculate it and find out. So we're going to say that the price of good X is equal to $1, and the price of good Y is equal to $5. So if I want to know how much person H is going to do, I need to find out what their MRT is. What's their marginal rate of transformation? What is their opportunity cost associated with producing one more of good X? They give up one good Y every time they produce more good X. So the MRT for person H is going to be -1 to 1, which is just -1. The ratio of prices is going to be 1/5, or you can calculate that out mathematically if you want, but we can see already that the marginal rate of transformation is greater than the ratio of prices. So in this case, this is for Hill, person H, because the absolute value of the marginal rate of transformation is greater than the ratio of the prices, they're going to produce X for person H, equal to 0, Y for person H equal to 4. That's their maximum right there. On the other hand, if we want to find the marginal rate of transformation for biliary, that's going to be the, 5 to 10. So that's a slope that tells us that every time they give up one good Y, they're going to get an additional 2 good X. That's a slope of 1/2, right? 1/2. So that gives us an MRT of -0.5 if we want. This stays the same, the ratio of prices. So in this case, because the marginal rate of transformation is greater than the ratio of prices, they should produce X for person B equal to equal to 0, and Y for person B equal to 5. Does that kind of make sense? So 1 is greater than 1/5, 1/2 is greater than 1/5. Neither of them produce any X, they both produce Y, and so we end up with a consumption point that looks something like, or a production point that is 9 total units of Y and is somewhere over here, right? Exactly right there. Does that make sense? Hopefully. I thought that was a good question. I thought that was interesting. If you have questions about that or anything else, let me know. Otherwise, that's the homework help I've got for you all today. Hope you have a great day, and I'll see you next time.